In this section, we'll have a look to remind ourselves of the different types of machine tools, their capabilities, and the types of parts that can be made on those machines. We're doing this because the more complicated the machine, the more expensive it is to buy, and therefore the higher its charge out rate, which means that if you can design a part to be made on a cheaper machine, then it will be cheaper for you to buy that part. Let's bear that in mind as we go through the next slides. This slide shows a typical CNC lathe. In the picture on the left hand side and again at the top right, you can see that the main part of this machine is a chuck that holds the workpiece and is driven by an electric motor. The workpiece usually starts off as a bar of material and is machined by tools held in the tool turret. The turret is shown in the photo on the bottom left and holds 12 to 16 tools for the different turning operations. You might have, for example, a parting off tool and cutters of different tip radii. The tool is moved by moving the turret head, and it can move forwards and backwards along the bed of the lathe, as well as towards and away from the centre line of the chuck. The typical parts that can be made in this way are long cylindrical parts, as shown in the picture on the bottom right. Note that this is quite a long part and a tailstock is used to support the far end. It is possible to get a turret head with live tooling, which means motorised tools. In this way, the turret can hold a drill, which can then drill perpendicular holes in the end of the part, so long as they align with a plane running through the centre line of the part. In addition to live tooling, you can augment some stations in the turret with a 90-degree gearbox, which means that you can now drill holes perpendicular to the side of the part, but the centre line of the tool must pass through the centre line of the part. On this slide, we can see a vertical machining centre. Looking at the machine configuration, we can see that the electric motor is mounted vertically and drives the tooling directly, whilst the part remains fixed to the bed. The bed can move left, right, forwards and backwards relative to the tool, and the tool can move up and down relative to the bed. This gives us 3 axes of freedom, which means that if any machining operations on the part are at an angle, it is necessary to machine fixtures to mount the part at that angle. This comes at a cost, as a fixture will cost something to design and manufacture, as well as the setup time required to mount the part on the fixture. The tools are mounted in a magazine, and a tool changer automatically swaps between the tools, though mounting the tools in the magazine in the first place is a manual process, and we find that operators prefer to use available tools rather than swap something out of the magazine, even if that means a longer machining time. A 3-axis machine is suited to parts that are machined from 2 sides, such as boxes and enclosures. On this slide, we can see a horizontal machining centre. You can see that the electric motor is mounted horizontally, and the X, Y and Z axes of movement are preserved. However, there is an additional 4th axis, described here as a B axis, which turns the rotary table. This machine works well for parts that have a machined surface around the outside, or require pockets, holes and drillings at different angles around the outside. The disadvantage, which can be seen from the part in the bottom right photo, is that it's not easy to machine the top and bottom surfaces, so more fixturing is needed. On the plus side, this machine does have 4 axes of movement, and that's often enough for some parts. It is possible to add a 5th axis, and we'll look at that after this short advert. Coming back to this slide, we can see a vertical machining centre where the bed has had an additional cradle added to it, which increases the number of axes to 5. The arrows in the left hand and centre pictures show the degrees of freedom. If you imagine a part is machined from a cube of material which has 6 sides, then the 5 degrees of freedom mean that this machine can remove material on 5 of those 6 sides, where the final side is the one that's bolted down to the machine. This means that you can manufacture very complicated parts, an example of which is shown in the photo at the top right. Of course, this means that the cost of the machine is much higher, and as a result, the parts will also be more expensive. But for complex parts, the setups to machine from different angles are reduced, and this time saving should offset the higher hourly rate of the machine. That concludes the refresher of different machine types. It should now be clear which machines have which capabilities, and that if you can design your parts to be manufactured from fewer sides and with fewer angles, they should be able to be manufactured on cheaper machines and so cost you less to buy. Please now move on to section 2 of the mini course.